Good morning. This is meteorologist James Longfier with Dynamic Weather Agency giving you your weather forecast update. In today's video, we'll be talking about severe weather today across the mid-Mississippi River Valley region and the Ozarks, heavy rainfall and the potential for flooding across parts of the southern Great Lakes, severe weather to continue tomorrow across the Appalachians, mid-Atlantic, and the Carolinas, along with a renewed severe weather threat for the central and southern plains, and storms across the Gulf Coast region. Before I continue with today's video, I do encourage you guys to hit that like button down below and subscribe to our channel if you haven't already. So be sure to go on down there and do that. It does help out that YouTube algorithm, allowing my videos to get viewed by more people, allowing me to do my part as a Weather Ready Nation ambassador with the National Weather Service to promote a Weather Ready Nation, conveying the message I have to the public. Also, head down to that description section of this video where you can find our links to our social media pages, along with our website, dynamicweatheragency.com, where you can find more weather information on over there, including forecast charts, radar, and much more. And last but not least, be sure to head on over to our Patreon page and help support this channel, allow me to continue to make content here on YouTube, such as chasing footage, funding our storm chasing and researching capabilities here at Dynamic Weather Agency, funding website upgrades, and much more I have planned for this channel. I put everything I can into this channel and my company, so there is some perks and exclusive content if you become a Patreon subscriber, including live content, Q&As, and much more. So be sure to check on that. Be sure to check that out. I do also appreciate you guys for checking out today's video. I did work a mid-shift last night, staying up just past, I should be asleep right now because I do have to go back in and work a mid-shift later on tonight. And that will dictate if I'm going to be able to make a live stream tonight, but I'm staying up for you guys so I can continue, so I can make you guys this video today to help you guys be weather aware about the severe weather today across parts of the, basically the mid-Mississippi Valley and parts of the Ozarks. Now, getting into today's video, I do want to talk about the severe storms we saw yesterday. Yesterday, we had that area of low pressure undergoing cyclogenesis, deepening overnight, bringing some elevated convection and storms across this slight risk area, especially over parts of northern Missouri, where large hail was primarily expected to occur, along with heavy rainfall. For the most part, the severe weather, there was a severe thunderstorm watch that was issued over the slight risk area, but for the most part, this forecast did not verify well. There was not much, as in for the most part. As we take a look at these storm reports for yesterday, 2 hail reports over parts of Arkansas, a few reports of hail over parts of Missouri, but most of it was sub-severe pea-sized hail, a few quarter-inch hail, but for the most part, this forecast did underperform for the most part, even with the area for the marginally damaging winds across parts of Oklahoma. The weather models were not suggesting that, and I thought SPC was going to take that on out. They did trim off the area. They did leave a small area in Oklahoma, and I think they should have just left that area on out for the most part. And I talked about that a little bit in our video yesterday, but for the most part, I did see the potential for the hail being there, so I do agree with the Storm Prediction Center with that, but for the most part, the forecast yesterday did underperform. Now, as we take a look at our National Weather Service hazards for today, one big thing that you see is there's a lot of green on the chart today, especially over parts of the southern Great Lakes region, parts of Illinois, and even into parts of northern Indiana, and that's for the basically flash flood watches. There's the potential for some heavy rainfall today and the potential for some flash flooding. You can even see some of those flash flood watches even extending all the way to the west coast, including parts of northern California and all along the California coast, where there's just a lot of deep tropical moisture moving on over the region due to an atmospheric river effect that we have moving on over there. And then you see all those yellows and tans over there. Those are for high wind advisories, watches, and warnings for parts of the western west of the Rocky Mountain region. Now, the main threat today is going to be talking about the severe weather threat. And this is going to be basically the big potential that we're going to be talking about today. So today, severe thunderstorms are expected across much of the mid-Mississippi Valley region, where we do have an enhanced risk for severe storms today. As we take a closer look at that enhanced risk for severe thunderstorms today, you can see places like Fayetteville, Fort Smith, Jonesboro, Springfield, Missouri, Columbia, St. Louis, Quincy, and just south of Springfield, Illinois, all within that enhanced risk for severe thunderstorms today, as noted by the Storm Prediction Center. Places like Burlington, Peoria, Evansville, Vincennes, Indiana, Little Rock, Arkansas, Memphis, and just east of Kansas City, all within that slight risk for severe storms today. Indianapolis, Lafayette, Indiana, Bowling Green, Tulsa, Omaha, you're all within that marginal risk for severe storms today. Now, all modes of severe weather are going to be possible today. First, taking a look at our tornado probability for today. There is a 10% probability for tornadoes. The greatest threat is going to be between Fayetteville, Springfield, Columbia, and St. Louis today, where that 10% contour for tornadoes is going to be today. Little Rock, east of Kansas City, Quincy, Springfield, Illinois, west of Vincennes, and Evansville, Indiana, and Memphis, all within that 5% contour for the possibility for tornadoes today. Like I said, all hazards are going to be possible today. Taking a look at our hail threat today, we do have a 30% probability for large hail greater than or equal to 1 inch today, mostly confined to central Missouri and most of Missouri today, into parts of northwestern Arkansas. Again, from Fayetteville all the way up towards Quincy today is where your greatest threat for severe hail is going to be. But if you're in Little Rock, Kansas City, Springfield, near Peoria, there's still the possibility for some significant hail today. The other major factor for today, damaging wind gusts. You can see there's a big 30% probability for damaging wind gusts. There's a little bit of a darker shade in the middle of there, and that's where that hatched probability is, where there's a great potential for damaging wind gusts within 25 nautical miles within any given point, as determined by that hatching by there. But again, a big swath of damaging winds expected today from Fort Smith all the way towards Springfield, Illinois, all the way towards Vincennes, back towards Columbia and Kansas City. Good threat for damaging wind gusts today. Now, taking a look again as an overview for today. Enhanced risk for severe storms in the mid-Mississippi Valley region. There is a threat for tornadoes today. More on that slight towards moderate threat with that 10% contour for tornadoes today. Hail and winds today. More towards that moderate threat for today. Higher threat for the winds due to that hatching, that 30% hatched hail threat for today. Now, as we take a look at our surface charts, as we were mentioning yesterday, we were watching this area of low pressure over southwestern Kansas, and we were expecting it to intensify and undergo cyclogenesis overnight. A short wave and a jet max was ejecting out over the Rocky Mountains region, and we were seeing increased divergence aloft, removing mass from the column, decreasing the surface pressure, and deepening the trough axis, allowing for thermal troughing and cold air advection to begin to develop behind the low pressure system, along with increasing warm air advection downstream of that low pressure system with the developing warm front, and increasing warm diabatics, allowing for the Pedersen's rule to take place, allowing for this baroclinic low pressure system to provide thermodynamic properties and kinematics conducive for severe weather today. As you take a look in time, you can see that low pressure system across the southwestern portions of Kansas slowly move its way to the northeast. That warm front becomes more well-defined, and then we have that defined cold front beginning to develop here at the very end. As we take a look at satellite imagery this morning, you can see that nice well-defined cold front stretching across Kansas, down into Oklahoma, into northern Texas, and then you can see all of that convective precipitation well ahead of that warm front, providing where we're seeing heavy rain and some showers and thunderstorms so far this morning. And you can see that low pressure system beginning to curl and wrap around on satellite imagery. So the next thing I want to talk about our severe weather ingredients. And typically we need to look at primarily 4 things for severe thunderstorms. And we're going to use the acronym SLIM here. Some like to use the acronym MILE, which stands for moisture, instability, lift, and exhaust. But I like to use the acronym SLIM, which stands for shear, lift, instability, and moisture. And the first thing we're going to take a look at is moisture. So yesterday we saw an increasing low-level jet ejecting rich tropical moisture from the Gulf in the warm sector of the surface low northward across the mid-Mississippi Valley up towards the southern Great Lakes region. Surface winds and dew points are forecasted to reach the mid 60s across the region, low to mid 60s, which will be sufficient enough for severe weather with the humid conditions present. Some of this moisture is spilling well ahead of the warm front. As we take a look here, you can see some of that moisture in the 60s and 50s spilling well north of that warm front, extending slightly above the surface towards the 850 millibar front. And this is all due to isentropic ascent within the warm stress sector, allowing for stratiform precip to form well ahead of the warm front, along with some showery precip where we're having some more of that forcing right along that warm front. And this is creating quite a bit of moisture, and we can measure that moisture by taking a look at our p-watts, and our p-watt values are ranging anywhere from 1 inch to about 2 inches within that warm sector of this warm front, indicating that we have a lot of moisture within the column present, suggesting that we could have possibly some very heavy rainfall. And that's all noted here by the Weather Prediction Center, issuing this moderate risk for excessive rainfall across parts of Illinois and Indiana with that slight risk around that. And you can see places like Peoria, Kankakee, Maryville, even places like Peru, up towards Logansport in Indiana, all within that moderate risk for excessive rainfall today. And places like Fort Wayne, South Bend, Kokomo, down just north of Indianapolis, including places like Carmel, even maybe places like Muncie, Champaign, Springfield, Rockford, down back towards Davenport and Burlington and Quincy, all the way back towards even just south of Cedar Rapids. We're all seeing possibility for some excessive rainfall, and that's denoted here by the Weather Prediction Center's Day 1 quantitative precipitation forecast for the next 24 hours. And you can see a big swath of excessive rainfall today, of 1 to about 3 inches of excessive rainfall expected across parts of Illinois and even into parts of Indiana today. And I want to highlight that here with my pen. Just take a look at this big swath of 1 to 3 inches of basically rainfall that's going to occur today from thunderstorms just kind of slowly moving across the area with some training of these thunderstorms, along with that forcing of that warm front and those high p-watts and that moisture due to that isentropic ascent moving on over that area is going to create some very showery precip, allowing for again this excessive rainfall. Next, taking a look at our instability. Now this is CAPE. This is convective available potential energy. This is measuring the kinetic potential energy stored in the atmosphere, indicating the air's positive buoyancy and that the air is basically wanting to freely rise in this area. So basically, CAPE is measuring the amount of energy in the atmosphere that thunderstorms can feed off of. So if any thunderstorms develop in this area, is able to tap into that stored energy and be able to grow and develop into stronger storms. So the stronger the amount of stored energy, the stronger potential for storms to grow. And not only is the amount of energy important, the amount of CAPE can also the shape of the CAPE on a SQT diagram could tell us about the speeds of the updraft and the strength of the updraft. And this is important considering hail, because stronger updrafts have stronger vertical velocities, able to spin hailstones up in the updraft longer, allowing for hail to grow in size. And this is also important, an important role when it comes to tornado genesis. Now, taking a look at our models, you can see the instability increasing in the warm sector as warm, moist air evects poleward from the south, and cool air moves over this region aloft, creating a unstable atmosphere. And you can see as we move throughout the day, due to diurnal effects, the instability is going to increase. And then as we move into the nighttime hours with radiational cooling, that instability is going to taper on off. Now, as we take a look at basically around 21Z, so 5 p.m. Eastern Daylight Time, 4 p.m. Central Daylight Time, you can see we have a very unstable atmosphere. You can see some of those values down there in those yellows are about 2,000 to 2,500 plus joules per kilogram. Now, typically, we can see tornadoes in as low as 500 joules per kilogram. Typically, we want to see values greater than or equal to 1,000, and we have values today between 2,000 and greater than 2,500 in this area, indicating that we have a moderately to very unstable environment. Another way we can measure instability is by taking a look at our lifted indices. So this is our lifted index. It is measuring the temperature difference between the environmental temperature and the temperature of a freely rising air parcel in the atmosphere in the mid-levels at about 500 millibars. And again, we're seeing some very unstable values. You could take a look at that legend down there, and a lot of values are greater than or equal to -6, which is indicating a very moderately to extremely unstable environment. Now, taking a look at our wind shear, the first thing I want to show you guys is our EHI, our Energy Helicity Index. This shows us where the best surface-based instability is and co-locates where the best surface to 1 kilometer wind shear is, since we're taking a look at 0 to 1 kilometer EHI. And basically what this is showing with that 0 to 1 kilometer wind shear is also showing us where the best streamlined vorticity is, making it a great indice to look at for the potential and prediction of tornadoes, because streamlined vorticity shows the low-level winds into the updraft of thunderstorms that gets ingested into the updraft, is then stretched, dropping the pressure within that mesocyclone within the updraft, lowering it towards the ground, increasing the mesocyclonic rotation within the low levels of the updraft, creating a strong vortex suction at the low levels. And you can see those EHI values of 2 to 3 to 4, even approaching 5 within that area, indicating the potential for possibly some strong tornadoes to develop of EF2 plus within the warm sector. And most of that is going to be kind of focused around where that triple point of that low pressure system is. You can see kind of where that cold front and warm front kind of meets, and most of that EHI is also going to stay right along that warm front. Any storms that are able to develop right along that warm front and ride that warm frontal boundary could be long-lived and the best tornado potential due to the very strong back surface winds and the strong storm relative helicity within that area. Now, we'll take a look at bulk shear a little bit more when we look at our forecast soundings just a little bit later on in this video. And we'll talk about storm modes and my thoughts about tornadoes as storms I'm expected, and the models are showing, becoming isolated and discrete to start off for the most part. But as we move in through the day, these storm systems are going to become more linear in mode and become more of these squall lines. And by the time when that happens, they become less favorable for tornadoes and more favorable for straight line damaging winds. However, we still cannot rule out the effects for a tornado just due to some of these strong surface winds, the backing, and this EHI indicating some good streamlined vorticity within that warm sector ahead of that cold front, and some of those prefrontal thunderstorms that could develop out ahead of that cold front. So taking a look at synoptically at what we have going on, first taking a look at our surfaces. Now this is going to be the Weather Prediction Center's Indy FD WSPC frontal forecast analysis. Now, as we take a look at this low pressure system, we do have the nice closed low here at the surface, a nice defined cold front and a nice defined warm front draped all the way across Missouri, all the way into the mid-Atlantic region, where you have warm air evecting well ahead of that warm front, again due to that nice strong low level jet and diabatic heating going on today within that area. That high pressure off of over the Carolinas is turning anticyclonically, evecting warm moist air across the region, and of course that air is flowing into that area of low pressure within that warm sector. As we move in through time, that low is going to slowly move off to the north and to the east. That cold front is going to become more well defined, and again that pressure system is going to be the synoptic forcing for the lift for most of the thunderstorm activity that we will see today. So this is our lift factor. Those frontal systems are going to be providing synoptic forcing due to those temperature differences and the confluence of winds along the front and a little bit out ahead of the front. There are some areas of converging winds out ahead of the front that the models are picking up on that could create some prefrontal thunderstorms. So that is the synoptic forcing and the lift of our SLIM acronym. So we talked about shear, we talked about lift, we talked about instability, and we will eventually, and we talked about moisture. So we have covered everything now needed for severe thunderstorms, especially tornadoes today. Now, continuing to take a look at what's going on synoptically. Now, this is our 850 millibar chart. So this is looking at about 5,000 feet above the surface. And as we take a look at what's going on here, we have a nice closed low now reflected at 850 millibars later on today, around 4 or 5 o'clock in the afternoon, Eastern / Central Daylight Time. And we have high pressure ridging in from the east to the west, creating an increased contour gradient as that low pressure system deepens at 850 millibars as we have that surface cyclone deepen, as we continue to have upper level support by the shortwave and the jet max, increasing divergence aloft on over the region. So at 850 millibars, we have that defined closed low over kind of southwestern Iowa with the strong low-level jet compared to what we saw yesterday. And then, like I said, this is due to that deepening low height center and interactions to that 850 millibar high to the east, creating an increased contour gradient aloft, along with cold air advection moving behind the low, increasing the thermal gradient too. This low-level jet is also responsible for transporting that low-level moisture and warm temperatures, along with generally large values of helicity, leading to tornado genesis. So it's very important to have this low-level jet across the region. Now, as we take a look at 850 millibar winds, at 850 millibars, we see that short wave has ejected over the Rocky Mountain regions. Now, full support of that surface low, stacking back towards the cold air aloft behind the 850 millibar surface low. And the short wave trough is aiding and deepening the upper level trough axis, along with cold air advection moving on in behind it. And the short wave is also promoting warm air advection out ahead of it, along with divergence aloft, upward vertical motion, and PVA or positive vorticity advection, promoting cyclonic spin. As we take a look at our vorticity chart at 500 millibars, you can see that area positive vorticity ahead of that shortwave trough, promoting that cyclonic rotation within the atmosphere. Now, as we take a look at 300 millibars today, compared to what we were seeing the other days, our PFJ was kind of discontinuous across the United States due to kind of a shortwave ridge over the area. You see some nice deep troughing now developing across the central portions of the United States, and that trough is going to continue to deepen as that jet max continues to dive south and move into that base of the trough axis. Out ahead of that jet max, we do have some diffluent flow, not as impressive as I was seeing the other day, but that's still promoting upper level divergence aloft and exhaust for thunderstorms across the area. And you can see a couple of jet fingers in some areas of shared energy across the Pacific Northwest and across the northeastern portions of the United States. And our STJ has moved well south across the CONUS, now along the Gulf Coast regions. Now, taking a look at this severe weather composite, this is a great composite to take a look at. And this is showing our surface-based CAPE at about 4 p.m. Central Daylight Time. And it's also showing our crossover winds. So it's showing our surface winds in red, our 850 millibar winds in blue, and our 500 millibar winds in black. So our surface winds are coming from a southerly direction. Our 850 millibar winds are coming from a southeasterly direction. And our 500 millibar winds are a little bit more westerly, but still kind of southeasterly across the warm sector. And I want to focus your guys' attention right on up here. And this area, I think, has some of the greatest potential for the possibility for the development of tornadic supercells today, because you're going to have a strong forcing from the cold front in this region shortly after the warm frontal passage, and your low-level winds at the surface are the most backed in this region, coming from the most southeasterly direction, and this will increase low-level SRH values within this region and streamwise vorticity for the most part within this region. So this is, I think, the best area for thunderstorm development, but I think anywhere along this warm front has very good potential because the surface winds are going to be backed along this warm frontal boundary, right along this area. So anywhere up there does have the potential for supercell development, but there is still that potential for thunderstorms to develop and tornadoes to produce along this region down here. Although we don't have as much low level turning of winds, there's still that potential there due to the strong surface winds and the backing, and the wind still veering with height. So taking a look at our sounding, this is our SKU-T log P diagram that we have here. And taking a look at the surface conditions, temperature 71, dew point 68. So we do have a relatively moist and surface-based type of storm system. LCL heights are quite low, as you can see right here. We do have a lot of CAPE, a lot of surface-based CAPE, increasing as we move into the mid and upper levels. We have more of a fat CAPE developing in there, and that's going to increase the vertical velocities and the updraft to be able to support hail growth within this region right here, which is our hail growth zone that we typically look at for hail. A little bit more moist than I would like to see. I typically like to see a little bit more mid-level drying within this region for that. Take a look at our storm relative helicity, over 300 meters squared per second squared. That's quite a bit of storm relative helicity. Surface-based CAPE, around 2,500 joules per kilogram. Lifted indices around -9, -8, so indicating we have a very unstable atmosphere to work with. Taking a look at our shear values. Shear is around, for surface to 1 kilometer, is around 35 knots, and I typically want to see that in my surface to 3 kilometers. So we have very strong surface to 1 kilometer wind shear, and like we said, that's going to promote a pretty good streamlined vorticity into these thunderstorms, and that's going to help promote tornado genesis within this, helping stretch those updrafts and lower the pressure, bringing that down to the surface, creating some of these surface suction vortices and stuff like that. Taking a look at our surface winds coming from the south, becoming more southwesterly as we move into the upper levels of the atmosphere. 850 millibars. We do have a 50-knot jet within that region. You can see this nice curved hodograph. Our storm motion vector is from basically the west-southwest to the east-northeast at about 40-45 knots. So storms are going to be trucking a little bit fast across this region. So that's going to be something to kind of watch out for. Again, this is a PDS TOR sounding. You can see that STP value around 4. With the mean value, so pretty good possibility to see EF0 to EF1 and possibly an EF2 tornado as we take a look at these box and whisker plots on down here, and even not a bad possibility to see even a EF3 just above the mean value based off this STP for a EF3 tornado based off those box and whisker plots down there. See quite a bit of analogs for supercells and a couple of matches for tornadoes, a couple of matches for SAR matches for hail, but no event matches for hail due to the sounding. And again, I think that's due to that moisture being in that hail growth zone within this area of the sounding. So mostly that's going to be if these storms transition and move over that warm front, ahead of that warm front. I think that's where most of that severe hail is going to be possible, and possibly more further on south along the cold front. Any thunderstorms that form along that area where the cold front may outrun some of those storms a little bit, increasing some of that cold and dry air aloft. All right, so taking a look at our weather models, this is the HRRR model, and taking a look at our FUTURECAST radar here. So as you can see right now, we are expecting all of that showery and convective precip to continue well ahead of that warm frontal area. And again, this is going to continue to move across parts of Illinois and Indiana where prolonged periods of precipitation, along with some training of these storm systems and those high P-watt values and the forcing from the warm front with that isentropic ascent over the region is going to produce quite a bit of heavy rainfall where we had those excessive rainfall, slight and moderate risk across those areas. And that's going to continue for a while, but we're going to move ahead in time to about 5 p.m. this evening. And around 5 p.m., 6 o'clock, we'll begin to see thunderstorms begin to develop right along that that active cold front region, moving across parts of Missouri and Arkansas. But one thing I do want to notice at the with this weather model, take a look at some of those thunderstorms that have and some of those more convective storms looking over parts of Illinois and Indiana right along that warm front. And that is going to be something to kind of take a look at if the HRRR model seems to verify or something like that, because the kinematic environment over there is very favorable for tornadoes. It's going to be all dependent on low-level instability on over that region, whether or not a decent tornado threat can actually develop across parts of Indiana along I-70 or just north of I-70. So that's going to be something to kind of take a look at if the HRRR model does verify. We will take a look at the NAM model here in just a little bit, but the HRRR has thunderstorms developing along the cold front, beginning to see some convective initiation around 5, a little bit better at 6 with some more thunderstorm development around 7 p.m. Eastern Daylight Time. Again, take a look at some of those thunderstorms that could be developed along that warm frontal region. Some isolated storms near the triple point, according to the HRRR model. These storms will probably be more isolated in nature as they develop, but they'll quickly congeal into a line and begin moving to the south and east, where they'll become more of a straight line wind threat as we move into about 10-11 o'clock at night. But we'll still have to watch for the possibility for some embedded supercell thunderstorms within that line segment to allow for basically the potential for tornadoes to persist even after the sun goes down, as we saw that EHI and even the Cape quickly decrease as the diurnal heating decreases with the sun going down and more radiational cooling beginning to evolve across the warm sector of this pressure system, where then as we move into about after midnight, I expect this to be solely a damaging wind event as this storm system continues to transverse eastward and northward as that low continues to track to the north and east. As you see, that low started back in southwestern Iowa, and by the time we move to the end of this model run, it's moved its way more towards the Peoria area. So it's continuing to move to the east and a little bit to the north as we go through time. So again, take a look at that FUTURECAST radar. So yeah, continuous convective precipitation north of that warm frontal boundary. We'll begin to see storm initiation between 5 and 7 o'clock along that cold front. Storms probably going to be discrete to start off, but quickly congeal into a line segment just due to the wind shear and the winds not really increasing much from the surface to 3 to surface to 6 kilometer shear that I would like to see, but so becoming more linear in nature. And we'll have to watch some of those storms along that warm frontal boundary. Like I said, kinematics are there. We'll just have to look and see if some of that surface instability will be able to support favorable updrafts for tornadic supercells to develop along I-70 region and I-74 back into Illinois if this model does verify. All right, now taking a look at the NAM model, for the most part, starting off, the NAM model is pretty similar to the HRRR model. A lot of precipitation well ahead of the warm front with some thunderstorms and some stratiform precip out ahead of that. As we move in through time, though, we'll see a little bit difference in the timing. This model has thunderstorms developing between 3 and 4 o'clock along the cold front, along with the potential for some thunderstorms developing ahead of the cold front as we move into about 5 and 6 o'clock this evening. Also, the difference of this model, there's not as much precipitation or thunderstorm activity along the I-70 and I-74 corridor as noted by the HRRR model, showing that most of the convective activity as we continue in through time, possibly moving well ahead of the warm front, becoming more elevated in nature, and then decreasing that tornado potential north of I-70 across Indiana and Illinois. So we have two different scenarios with this, and you can see here this model indicating some more discrete thunderstorm development along the cold front, some thunderstorms developing well ahead of that cold frontal region as determined by the NAM model, but then quickly congealing into a line as we move in past 9, 10, 11 o'clock, where we'll start seeing that damaging wind threat becoming more predominant. Now, not only are we tracking the risk for severe storms today, We're also monitoring the potential for severe weather tomorrow. So tomorrow there is a slight risk for severe thunderstorms across parts of the southern and central Appalachian mountain region, including parts of the mid-Atlantic and parts of the eastern Carolinas. As you take a closer look, this includes places like Charleston, West Virginia, Richmond, Roanoke, Raleigh, Charlotte, North Carolina, just to the north and west of Columbia, to the north and east of Atlanta, and including places like Knoxville, Columbia, Wilmington, Virginia Beach, Baltimore, Reading, Pittsburgh, Atlanta, all within that marginal risk for severe storms tomorrow. And the primary threat with this storm system is more going to be damaging, straight line damaging wind gusts as we move into tomorrow. And then as we move into Tuesday, we're going to be watching the regeneration of severe thunderstorms across parts of the southern and central plains, where the threat for damaging winds, possibly tornadoes, and hail will return across this region. And then as we move into Wednesday, there is going to be the potential for severe thunderstorms to develop along the Gulf Coast region for places like Louisiana, Mississippi, Alabama, and parts of the Florida Panhandle, including places like New Orleans, Biloxi, and Mobile, Alabama, all within this area for the potential for severe weather to develop as we move into Wednesday. Again, I'd like to thank you guys for checking out today's video. Be sure to like and subscribe to the channel if you haven't already, and be sure to head on down to that description section of this video and check out some of those links to our social media, our website, and our Patreon page to help support this channel. Last but not least, I want to thank you guys for checking out today's video. Be sure to stay tuned. I may go live later on today, depending on timing. I just got off of work earlier this morning, working a mid-shift, doing weather for the Air Force, and I'm staying up just to create this video for you guys. I'm getting ready to go to sleep, and then I'm going to wake up, and depending on the timing of these storms and when they develop and how the severe weather is unfolding, I may or may not go live today. So that will be the reason if I do or do not go live today. Again, thank you guys for checking out today's video. I hope you guys have a great and wonderful day. I'm meteorologist James Sullivan signing off.